Hello, and welcome back to the Top of Machine LLC fan club, or whatever this is. Stuart Shenanigans or something like that. I'm Stuart, and this is where my shenanigans happen. So, what's going on with the Cincinnati mill? Well, the eagle-eyed among you will observe that it's mostly back together at this point and not before time. The last parts to cover are the repair of the pulley sheaves. Now, if you watched one of my previous update videos, you will know that I welded these cast and machine pulley sheaves in order to build up material on the broken parts so that I could machine them back. Well, just to cut a long story short and save a whole bunch of excessive intro, that worked on one and not the other, and this is the other. And what happened was, as I was manipulating this and getting it ready to machine after welding, this chunk broke off. Now, it didn't break off at the weld is, well, this side of this, but I wasn't handling this in a very rough manner, and yet it broke again. So at that point I said, well, sod this for a game of soldiers. I've got a chunk of material anyway. I'll make my own damn pulley sheave. So what I'm going to be covering is the repair of one and the manufacture of another. And I've decided that I'm going to wrap this series of videos up in 3 more videos just to try and keep them a little bit reasonable in length. So the first one will be the weld and repair of the larger, which is the idle or jack pulley sheave. And the next video after that will be the complete manufacture of a whole pulley sheave from a block of cast tooling plate. And then the final video will be a short one, which will just be test running the machine and the last few bits and pieces, getting it set up and ready. As you can see, it's mostly back together. It's cleaned up nicely, just a few little bits of cosmetic work on the handles and polishing and things just to make it good, and cleaning and getting all the grit and grime out of it have done wonders for it. I'm about ready to tram the head in, and I've got a new tool to do that, which I purchased from DeBolt Tool when I was out of the Indiana Model Engine Show. It's a tramming ring. And basically what that is, that's a ground, very flat ring of steel. I was going to get one of these made, and then I discovered that Paul DeBolt of DeBolt Tool sells these, and I asked him at the show how flat and parallel they were, and he sort of nodded and said, well, you know, about 5/10. And I thought, wow, that'll be good enough. And I don't know what the variation on his rings are, but my one is like 1/10. And that's 1/10 combination flat and parallel. I haven't measured the flatness, because what I'm really interested in is just projecting this plane up to a continuous plane. And when measuring this on a surface plate, it comes out about 1/10. So I'm very happy with that. Anyway, that's the last few things to do. So for this video, let's get on with it. Take a look at repairing this pulley sheave, and then in quick order another video will come out around the manufacture of a new one, and then the third video, as I say, wrapping it all up. This is all based very heavily, this repair of this sheave, on a video that Max Grant did when he repaired one for his shaper. And so a huge amount of thanks go out to him for making that video in such detail, because that was very, very helpful to me in getting this job done and getting the mill back up and running. So with that, please like and subscribe. Hope you enjoy the video. Wherever you are in the world, stay safe and well. And as always, be seeing you. So what I'm doing here is just machining off the damaged areas of the pulley sheave, thereby taking out any contamination. I'm making a point of doing this dry with no oil, coolant, lubricant or anything to make sure that the aluminium stays as clean as possible for the welding. And all we're doing here is cutting out some additional pieces of aluminium to weld on to build up the material on these two sheaves. Now in retrospect, might have been easier, probably would have been easier to just build up weld beads, taking my time, you know, and building up steadily and slowly, but this did kind of sort of work out. And here we are behind the welding mask. So initially what I'm doing here is just using the torch to preheat the two parts a little bit, and I'm taking my time before adding in the first tack. Aluminium is really sensitive when it comes to welding, so I'm really here just taking my time, making sure that the parts are up to temperature and making sure that that tack sinks in. And then at the end of placing the tack, I'm trying to ramp the power down so that the little tack weld doesn't crack. With that done, I'm now doing much the same thing, and you'll see me moving around here, and I'm just using the plasma on AC to clean the material and heat it up in an attempt to get rid of as many contaminants as possible. So this is very low current at this point. It's just enough to do some etching and to put some heat into the part, and after this I'll bring the power up and actually start running a bead of sorts. Certainly I'm no expert at this, very limited experience, so this is not meant as any kind of tutorial, just showing you what I did to repair these two components. When you look at this, you can see it's taken far too long running along here, and and in the event did not sink that bead down enough, and I had to come back and do it again. By do it again, I mean come back over it, remelt the bead, sink it down and add more material. I didn't grind it or cut it out. And off we go cleaning up the welds. So I'm just taking it very easy here because obviously the welds are built up and very uneven, and so I don't want the tool to dig in and pull the part out of alignment. What I'm doing is I'm using the old jack shaft from the milling machine as a mandrel to hold this part, and then using the set screw in the pulley sheave to hold the pulley sheave tight on the keyway groove in that shaft. So it's pretty well supported, but even so, it's worth just going easy and lightly to take those first welds off. And what I'm using here is actually the only brand new Kennametal turning tool that I've got, because it was the only one I could find in this particular configuration to use one of the unused corners on a CNMG insert. But this works very well for just taking the tops off of those welds. Right, let's have a look at this. As I was cleaning this face up, I became increasingly irritated with the amount of run out on it, which measures at about 20 thou. Now, 20 thou run out on a V-belt cone pulley is irrelevant to the drive itself. These are plenty forgiving and more than capable of dealing with that. That amount of run out won't even transfer through to the main machine spindle. But the problem is that while I'm trying to get this weld material cleaned off, I really want the pulley running as true as possible so that I can blend the machined weld surfaces into the existing V-belt groove surfaces. So I have to do something about it. But then in examining it, I realize, and I already knew, that this has been repaired before. This bush in the middle here is a repair done by some person. So you can just see the original keyway, what's left of it. And I knew that was the case. This is a very shallow keyway here. And I was fine with that until I now realize that it's not centered properly. So what I'm going to do is push that out and make a new bushing, which will either look a lot like this one, or probably more likely is I'll completely machine off the remnants of this, you know, damaged boss here and make a new bushing that just replicates that entirely. And it seems like there's quite a lot of material. In fact, there's lots of material there. So I will very likely make it a top hat bushing with a flange on it that can be recessed in the top here with 4 screw holes to make absolutely sure it doesn't twist when it's in service. And that way that gives me more material for a proper keyway as well. So that's next. And then I'll machine out the bore in the bushing, actually in the lathe. What I'll do is put this up in the forge jaw. Got this nice machined surface in here, which I'm very sure will run true to the V grooves, and I'll check that. But given that I'll put this in the forge jaw, I can hold it very securely and bore out a hole for a new bushing, and then bore the bushing ID out to run very true. Right, so I've got this set up on the forge jaw, and it's being worn. It's a bit tricky to get it properly concentric. So I've clocked these 3 grooves on both the ID and these ODs and kind of balanced it out as best as I can, and I've got it running within about 2 or 3 thou on each surface. So that means the spindle axis is it's not 2 or 3 thou in at the same place on it in every surface. If it was, then I'd just offset it 3 thou and it'd be perfect. But it's all over the place, which means that the axis is doing this. But it's only doing it within 3 thou, which for a V-belt pulley is absolutely fine. I'd love to get it better than that. The only way I can get it better than that is to actually skim material off of all these surfaces, which may happen as I dress it up. But for the time being, that means where we're at is this is plenty good enough for the repair it's going to get. It's certainly way better than it was. So the next stage is to bore out this hole, which will remove the boss from the inside, and then we'll make a new boss to press into that hole at whatever that ends up at. It's going to be about 1.3 inches, and then once that's done, I'll machine the final bore into that boss, and at that point we'll dress up the welds and clean this up, and then broach the keyway, and away we go. So for now I'm going to just take a light cut across this surface and clean it up, which will be a reference surface for reinstallation after pressing in the boss. Bore this out, and that's it for this operation. I'm not going to clean up. Well, I might come and clean up some of this weld material just since it's here. But since it's here, I could actually finish that. I'll see how I feel about it. You want to be on the high spot of the sheave, cylinder, whatever it is you're working on. So that you know you're right on top of the axis that you're trying to get aligned. Yeah. In neutral. Yep, there we are, 12. 11. I like to use the 2 key method for adjusting forge jaws and other items. Wrong way. Go halfway. Ish. Yeah, 1.5. Let's see how that looks when I run it. Well, that's running really nice now. Hopefully you can see that on the camera. That little bit of extra work was well worth doing. Okay. We'll slow this down. I'm going to run 340 RPM. Now I've already set this tool up to make sure I can get it right in the corner of these faces when I turn it, and that's the advantage of this nice profiling tool. I can do that, but I can only do these rear faces. If I want to clean up the others, which I don't need to, I would have to turn this to 17 degrees going the other way. Right. This is all exploratory. So initially I'm just going to clean up some of this material. Well, I'm making it up as I go along at this point. I switched over to this CNMG type insert, which is just a lot tougher and better for interrupted cuts. Since I had to do a little bit of weld repair on the second lip of this particular part of the sheave, I did have to set up the compound slide to be able to dress up this face. So that's all you're seeing here is just a little light cleanup and kind of a better view of what's happening with this profile tool as I go in to make this pulley sheave good.
Hello, time for the next bit. So, where are we at? We're out in the outer part of the shed with the pressing apparatus, and here is the welded and machined, partially repaired sheave. I'm actually pretty happy with how that came out. And here is the boss that I have to now press into the middle of it. Now, took a tip from Max Grant, who, when he does something like this, turns just a little short. You can just see that at the top where my finger is. Slip fit section, so the boss will align easily in the bore of the hole it has to go into. Now, when I've done these in the past, I've put a little taper on the front end there to sort of ease it in, but this little short straight section is better because it actually gets it aligned better. On the taper, you're just sitting on a single ring and you can still cock the thing over. Anyway, this has something like a 2 thou interference with the hole. That's a massive amount, and I am not confident that I can press it all the way in with this piece of equipment, this 20-ton press. If you've never worked with that kind of thing before, it's difficult to understand just how much interference that is. A bearing interference for a ball or roller bearing into a housing is tenths of a thousandth of an inch, which is enough to hold it in place and still allow you to press it back out again. And the exact amount depends on the size of the bearing. There's a lot of tables and things to help you figure that out. This is a permanent install, and the amount of crushing that happens on the material at that level of interference is immense. And if this gets hung up part way in, it isn't moving in or out again, not with this equipment. The only way it's coming out is to be machined out, and I really don't want to go through that. So, to aid in that, I asked the domestic authority if I could heat this up in the oven in the house, and I don't actually know what some of the words she said meant, but it sounded very negative. So I'm going to use my little toaster oven in the shop, which is used for reheating stuff. And this I'm going to chill in some dry ice, which I have in the cooler just down here, and I'll show you in a minute. Liquid nitrogen would be better, and if I put this in liquid nitrogen, chances are it would contract enough to go in there without this needing to be heated. But liquid nitrogen is a little more difficult to get, a bit more expensive. I mean, it's not difficult to get, except that the place that sells it is closed on Saturdays. Whereas dry ice you can buy from a lot of grocery stores, which is what I did this morning. So, and it was Halloween the other day, and I was phoning around trying to find which stores had dry ice, and the people that answered the phone at the various places were really annoyed. I guess Dry ice at Halloween is a thing, and I was the 30 millionth caller that they'd had asking about it, and so some of them were getting upset, which I guess I understand. Anyway, it's a bit expensive, and I could probably achieve what I need to do just by putting this in the freezer, but you know, dry ice. And if there's any left at the end of the day, I might put a couple of chunks in my Manhattan, and maybe I'll show you how to make a Manhattan. So let's chill. As exciting as it sounds, dry ice, which is just carbon dioxide, that's all it is. It's just a solid bunch of stuff. But listen to that go. That's the effect of a room temperature piece of metal being put in the chunks of dry ice. There's way more in there than I need, but like I say, Manhattans. Don't touch it with your bare hands. It burns. So, and what happens with dry ice, it doesn't go through a liquid phase when it evaporates. So it's not evaporating, it's what's known as sublimating. It will go from that solid block into a gas, and the cold gas condenses water in the air, you know, water vapor, and that's what makes the mist and stuff that comes off of your nighttime brown drinks when you use it in that way. Right, so while that's chilling, I'm going to put this in the oven. Not the one in the house, because that apparently would have me banned for all eternity from the planet. Right, well, I think we're ready to go here. I'm now going to go and retrieve the pulley sheave. Easier to do it like that. And the boss is at a temperature known as quite cold. See? Oh, see, that's exactly what we want. I don't even need to press it in. Yeah. Well, that certainly that was certainly drama free. I didn't want the boss to get hung up in there pressing it in, and it just went straight in. Look at that. Yeah, perfect. Well, yeah. So I could probably have had another thou of interference, but anyway, we'll let that warm up and that cool down, and go on to the next step. So what I'm going to do, shouldn't need it really, but I'm going to put a Scotch key in this, and if nothing else, that will give me a chance to show you what a Scotch key is. I don't think it'll need it, but I'm going to do it anyway, just because. The remnants of a piece of dry ice in my bubble water beverage. That's quite fun. Now, what is a Scotch key? Well, it's actually pretty simple. It's a pin that is driven into two cylindrical objects that are being keyed together, and so what you do is drill a hole right on the OD of the boss and on the ID of the part it's gone into. And the Scotch key itself can take the form of a tapered pin or a round pin, or in this case, I'm going to use a 1/4 20 grub screw or set screw, depending on where you are in the world. I always like calling them grub screws. It's very sort of descriptive of what they are. I only need one. I'm actually going to put two in it just because I like symmetry. Can you hear that? Isn't that great? All right. So all this is a drilling and tapping operation, and I found the center of this part because I lightly skimmed the OD of this sheave, and that gave me a reference. I haven't filmed any of this because it's just, you know, regular stuff. And honestly, this is just drilling and tapping. So I'm just going to center drill 2 positions, drill and tap, and I guess might as well film it, and then you'll know what a Scotch key is. I've been using this Hangstafers Super All Tap. I saw Matty in Matty's workshop use it in a video, so I thought I'd try it. I know Anchor Lube is all the rage, because it's good stuff, Anchor Lube. But so is this. It's great. It's really sticky. Stays put. It's specifically a hand tapping stuff. And here I'm using my super special, specifically designed for this purpose, Edge Technology tap wrenches, which, you know, I like. Yeah. There we are. So now I'll put a couple of grub screws in there and get it on the lathe and finish it off. Now I'm not going to film making the bore in it. I mean, that's just the same as we've already seen. I just have to get this up in the forge or center it, which I can do because I've got several diameters that are cleaned up now I can reference, and I've also got this flat face I can reference. I'm going to put this on the forge or chuck, hold it the way I did to bore this out, drill undersize and then bore through accurately, and then this one's ready for broaching. Oh, there is another part to the story which I have to take care of. Which is, this boss had to be this big in order to properly repair it, but I have to turn this down a little bit on the inside here because this will ride on both the inner and outer race of the bearing, which is no good. I only want it to ride on the inner race, so I got to just take off a little bit. But I'm going to do all of that off camera. Oh, one other thing I have to do after I've bored it, I have to drill and tap that all the way through, and I want to do that after I've put the through hole in. So a couple more operations to do yet, but I'm going to do all of that off camera because that's all pretty basic stuff. After a day in the shed, it's a good idea, or at least very pleasant, to have a nice cocktail. There are several important things that you need for a cocktail, and I'm going to show you how to make one of my favourite ones, which is either an old-fashioned or a Manhattan. I can't remember which, I just know what stuff to mix up. First thing you need is a cat to look at you in disdain. Meet the Flash. Isn't he lovely? What a good boy. Right, off you go. Now, to the cocktail. You need some whiskey, not single malt. You don't mix single malt. Okay? I don't want to hear anything about it. You don't do that. So, we'll use this. Some of whatever this is, vermouth. A vessel to put it in. Some delicious cherries. And some Angostura bitters. And then, for effect, something magical. We'll get to that in a moment. But come down here and let's take a look at the drink. So, couple of cocktail cherries. Dash of Angostura bitters. That's probably too much. You don't need much. One part vermouth. Two parts Canadian whiskey. And now, dry ice. There. Don't you wish you had one? Cheers.